So what is HVAC? HVAC are initials for heating, ventilation, and air conditioning. HVAC stands for heating and cooling of both residential and commercial buildings, as well as the many systems utilized to move air between indoor and outdoor locations. They are the systems that keep you pleasantly warm in the winter and cool and refreshing in the summer. They are also the systems that filter and clean indoor air to keep you healthy and maintain comfortable humidity levels. A radiant system combined with window air conditioning units, for example, could be different components in your home. Combination systems such as central heating and air conditioning that employ a single blower to circulate air through internal ducts in a home, or ductless system for different rooms or zones in the house are more frequent. An HVAC system serves a purpose beyond the simply heating or cooling a space. Instead, it improves interior air quality and provides comfort for everyone inside the structure. While HVAC systems come in a variety of shapes and sizes, they all start with the same basic components. HVAC basic first and foremost, there is a source of fresh air intake from the outside or within the residence. Ventilation is the term for this process, which occurs in two ways. Most homes have natural ventilation, which refers to how air travels in and out through windows, doors, vents, and other openings. This air exchange is required to replenish oxygen while also removing smells, carbon dioxide, and excessive moisture. To move air in and out, mechanical ventilation employs a mechanical system. Gaps and crevices in the building, as well as openings and closing doors, provided ample natural ventilation in most homes in the past. Contemporary buildings, on the other hand, is resulting in homes that are much more tightly sealed. Therefore, ventilation is becoming a more vital component of residential HVAC systems. The air is drawn into an air handling unit where the job begins when it is brought in. Filters are used to remove dirt, dust, allergies, and other particles from the air. Heat is applied to the air, or it is cooled and excess humidity is removed. The air is delivered into the residence once it is clean, fresh, and at a comfortable temperature. For central systems, this entails traveling to other rooms via a network of ducts and registers. In the case of other systems, this usually entails being directed directly into space. Local shopping centers generally incorporate an enclosed, heated, and air-conditioned mall developer, who may be an independent party, a financial institution, or one of the major tenants in the center. Normally owns these centers. A huge number of people and numerous interior heat sources load shopping centers, shopping malls, and stores. Internal heat created by lights, people, and computers can be used to heat the building in the winter, but it should be swiftly and efficiently driven out of the structure in the summer to avoid further cooling. With proper air exchange, you can achieve the best balance of light, comfort, and ventilation expenses. The enclosed mall's air conditioning system is provided by the developer or owner. A central plant or unitary equipment may be used in the mall system. The owner usually mandates that each tenant store linked to a central plant system and includes heating and cooling charges in the rent. When unitary systems are employed, the developer usually compels each tenant to install a unitary system with a similar design. The developer's criteria for conventional heating and cooling systems may or may not be adequate to meet the tenant's individual needs. In some circumstances, the renter may be required to install a system that is not the same sizes as the developer intended.
And now we're going to be talking about interior design and HVAC for retail. Provisions in leasing agreements that are harmful to conservation may be included, such as allowing excessive lighting and outdoor air or deleting requirements for economizer systems. The utilities representative should collaborate with the designer to understand the lease requirements and work closely with leasing agents to help these systems become more energy efficient by including heat pumps, thermal storage, and other energy-saving technology. Food courts can be found in most large retail malls. These require unique considerations for odor control, outside air requirements, kitchen exhaust, heat removal, and refrigeration requirement. In a typical system, HVAC system, shopping malls come in a variety of shapes and sizes, as well as architectural designs. For a mall and tenant air conditioning, single-level and smaller centers typically employ unitary systems. Multi-level and bigger centers often use central plant systems. The mall system is designed by the developer, and equivalent procedures are typically required for tenant stores. At the local usage point, a typical central system may send chilled air to individual tenant stores and the mall air conditioning system, with variable volume control and electric heating. Some systems are capable of distributing both hot and cold water. The energy services available at shopping malls are comparable to those in department stores. Some shopping centers can successfully use cooling tower heat exchanger economizers where a central chilled water system is built. Regional shopping center central plant systems often have lower operating costs than unitary systems. The initial cost of a central plant system, on the other hand, is usually higher. The types of HVAC systems. Now we have a single zone. A single zone HVAC, if the areas served have equal heating, cooling, and ventilation requirements, or if the control system accounts for variances in heating, cooling, and ventilation needs among spaces serviced, a single air handling unit can only serve more than one building area. Zones are defined as areas governed by a single control, for example, a single thermostat. Next is a multiple zone. By heating or cooling the airstream in each zone, multiple zone systems can give air to each zone at a varied temperature, using a supplementary system to modulate room temperature or supplying air at a constant temperature while altering the amount of airflow are two more design methods. Examples are perimeter hot water piping. Next, we have constant volume. Constant volume systems, as the name implies, provide a constant flow of air to each location, not by regulating the volume of air provided, but by heating or chilling the air or turning on and off the air handling device. Changes in space temperatures can be produced.
Another type of HVAC system is a variable air volume system or VAV. Rather than adjusting the air temperature, variable air volume systems maintain thermal comfort by varying the amount of heated or cooled air provided to each location. Because VAV systems can meet varying heating and cooling needs of different building zones, these systems are found in many commercial buildings, such as shopping malls especially. VAV systems offer superior performance and energy savings for a higher upfront cost. In most cases, they are the best option because long-term energy savings far outweigh the additional system cost So variable air volume systems are energy efficient and they do not have much additional system cost. Next is, this is a typical HVAC system. As you can see. Another type of system is outdoor air intake. Before being distributed, outdoor air supplied through the air handler might be filtered and conditioned, which basically means heated or cooled. Other designs may use air-to-air heat exchangers and movable windows to bring in fresh air. When toxins from the outside air enter a structure, it can cause difficulties with indoor air quality. Air intakes on the roof or on the wall are sometimes placed next to the or downwind of building exhaust outlets or other pollutant sources. Outdoor air will enter the building at any leakage locations in the shell if more air is expelled than is admitted through the outdoor air intake. If the leakage source is a door to a loading dock, parking garage, or another polluted area, indoor air quality issues can arise. Another one is mixed air plenum and outdoor air controls. These systems is in the mixed air plenum of an air handling unit. Outdoor air is mixed with return air or air that has already circulated through the HVAC system. If the outside air damper is not performing properly, for example, if the system is not constructed or altered to allow the admission of adequate external air for the current use of the building, indoor air quality concerns are common. In the occupied mode, the amount of outdoor air provided should be sufficient to meet ventilation and exhaust makeup requirements. It might be set at a constant volume or change in response to the outside temperature. When external air dampers are structured to modulate, they are normally designed to bring in a minimum amount of outdoor air in the occupied mode under extreme outdoor temperature conditions and to open as outdoor temperatures approach the desired indoor temperature. The term air conditioner cooling refers to the cooling systems that utilize outside air. A mixed air temperature controller and thermostat are used in air economizer systems to blend with return air. It is usually at 74 degrees Fahrenheit. With outdoor air to achieve a mixed air temperature of 55 degrees to 65 degrees Fahrenheit or mixed air temperature settings above 65 degrees Fahrenheit may result in sufficient amounts of outdoor air being introduced for office area utilization. If the airstream temperature goes below the set point of a freeze stat, many HVAC designs safeguard the coils by closing the exterior air damper. If a freeze stat trips and is not reset, or if the freeze stat is configured to trip at an abnormally high temperature, inadequate ventilation can result. Stratification of the cold exterior air and the warmer return air in the mixing plenums is a common problem that causes the freeze stat to trip.